Hello. Today we're going to be multiplying and dividing rational expressions. A rational expression is an expression that can be written as a fraction, so we're going to be dealing with a lot of fractions in this unit. So the first thing we're going to be talking about is how to simplify rational expressions in general. So for instance, if we had something like 10 over 25, you could look at this and you can say, hey, 10 divided by 25, I know what that reduces to. That's going to be 2 over 5. But the question is, why does it reduce to 2 over 5? And so looking at this, you'd say, okay, they both divide by 2, or not by 2, by 5. But what's happening here is 10 is 2 times 5, and 25 is 5 times 5. So what we're doing is we're reducing out a common factor. So we're going to be doing this. We're just going to be doing this with polynomials. So in order to reduce rational expressions, you have to reduce common factors. Now, I am saying that word factor, which means you have to be careful. Here's a critical error for this unit. Okay, this is something that happens all the time, but this is a critical error. Someone looks at this and they say, hey, I'm going to go ahead and I'm going to cross off the x squares and I'm going to cross off the x, and it is just 2 over 5. So this is not okay. In order to cancel things out, you have to cancel out factors, which means you have to factor things first. So let's go ahead and take a look at examples 1 and 2, and then after we simplify them, we'll come back to something called excluded values. So for example 1 here, we cannot cancel out any of the x's, we can't cancel out x squareds, we can't reduce any numbers here. We have to factor. So we're going to take our numerator, and that's going to become a 3x and an x plus 5. Our denominator here is x squared as a GCF, squared plus 7x plus 10. So almost there, not factored yet. We get 3x and x plus 5 over x squared, x plus 5, x plus 2. Now these are factors, so we can reduce out common factors. So we're going to cancel out the x plus 5s. We have 1x being multiplied on the top and 2 in the denominator, so we also can reduce out an x. Which means our final answer for this one is going to be a 3 over x and x plus 2. You can just leave your answer in factored form. So let's go ahead and try number 2. We're going to factor this one. So for the first one, we're going to factor by grouping. We get x squared minus 4 and x minus 3, which means it's going to factor to x minus 2, x plus 2, and x minus 3. Your denominator here, you're going to use your difference of cubes. So think back to chapter 6 here. So it's a cubed minus b cubed. So x is going to be a, and 3 is going to be b. So it's x minus 3, and then x squared plus 3x plus 9. And now we can go ahead and reduce out common factors, the x minus 3's. So we would get x minus 2, x plus 2, and then x squared plus 3x plus 9. This denominator here would never factor once you use your difference of cubes. So this would be our reduced answer. Now, every time we have a fraction, we have to make sure we're not breaking any rules. Now, rules with fractions include like everything needs to be reduced, but you also cannot divide by 0. So over here, anything that makes the denominator equal to 0 is going to be a no-go for these ones. So those values that make the denominator equal to 0 are known as excluded values. So for each problem here, what you have to do is you have to look at the denominator, and you want to do it before you cancel things out. So we want to look at all of the factors of the denominator, and we're going to set each factor equal to 0 to find our excluded values. So for this one, our excluded values would be x cannot be 0, x cannot be -5, and x cannot be -2. Those are all the values that make the denominator equal to 0 in the original problem. So looking at this next one here, so we are going to take our denominator and we're going to set it equal to 0. So we get x minus 3 equals 0, and x squared plus 3x plus 9 equals 0. So our excluded values are going to be x equals 3 from the first equation. And then for the next one, you'd have to do your quadratic formula, and you would get some imaginary answers. So we're not going to deal with those. We're only going to deal with the real excluded values. So x cannot equal 3. So then we're going to move on to multiplying rational expressions. So to be honest, you have a couple of options here. Let's say you had 3 over 2 times 6 over 4. I'll make it 6 over 9. Okay. Option number 1 is to go ahead and actually multiply and then reduce. But option number 2 is to say, well, we also can reduce a little bit easier. So 6 divided by 2 is 3. 3 divided by 9 is 3. And 3 over 3 is 1. You get the same answer if you reduce first or if you multiply first. Now, because we want our lives to be a little bit easier, now imagine multiplying polynomials. That's not going to be as nice. So what we're going to do is we're going to factor things if it's multiplying and reduce, and then you can multiply across. So for 3, I see x plus 2 as a factor in each of them, numerator and denominator. 3 over 6 is going to reduce to 1 over 2, which makes my numerator x squared, and my denominator a 2 and an x plus 1. For my excluded values, x plus 2 can't equal 0, x plus 1 can't equal 0, and 6 is just a number, so that's not going to yield an excluded value because there's no x. So what I'd like you to do is pause the video, factor number 4, cancel things out, and then find your excluded values. So let's see how we did. 2 factors would cancel out. It would be x minus 2 and x plus 2. Your numerator would be x plus 1 and x minus 3 being multiplied together. Your denominator is x minus 1 and x plus 3. And your excluded values are all of the values in your denominator, so there are 4 separate factors here that cannot equal 0. So now what we're going to do is we're going to work on dividing rational expressions. So there's a couple of different things you can think of with dividing. We are dividing fractions within fractions. So for instance, if I had 1/2 divided by 1/4, we don't really like looking at that. What we do is we leave the numerator alone, we take the denominator, and we multiply by the reciprocal. And so our answer for this one would end up reducing to just 2. So it's going to be the same if you're written as a complex fraction or if it's written out 1/2 divided by 1/4 this way as well. So both of these are the same problem. You're going to take whatever you're dividing by, you're going to take the reciprocal of it, and you are going to end up multiplying it instead of dividing it. So the only thing with this one is excluded values. So if you're looking at your denominators, b is a denominator and c is a denominator. So b can't equal 0 and d can't equal 0. But when you flip it, you also end up with a new denominator. So c can't equal 0. So for simplifying these and writing your excluded values, anything that was ever once part of a denominator, either initially or when you flipped it, can't be 0. So let's take a look at number 5 first of all. So notice how it's already in factored form, which is nice. We're going to leave our first fraction alone. We're going to change the division to a multiplication, and only the thing that comes right after the division is actually being divided. This is where we're going to flip our numerator and our denominator. So we have x plus 2 and 5 in the numerator, and 4x and x plus 1. So the x plus 2's are going to reduce, one of your x's are going to reduce, and we're going to do 3x times 5 over 4 and x plus 1. For our excluded values, we're going to go back and we're going to figure out whatever is in a denominator. So x plus 2 is in a denominator, so x can't equal negative 2. X plus 2 is also in a denominator, so we already have that one covered. And then x plus 1 was in the denominator, so x can't equal negative 1. But then we also had this x here that got reduced away, so x can't equal 0 either. So let's go ahead and try this next one. It's not factored for us, so we're going to go ahead and factor. Our numerator becomes x plus 2 and x plus 1. Our denominator is x minus 2 and x minus 1. And then you can go ahead and factor both your numerator and denominator, but because it's division, when we write it as multiplication, we're going to flip our numerator and denominator because we're taking a reciprocal. Once we do that, we can go ahead and reduce out the common factors. So x plus 2 would reduce out. The x minus 1 would reduce out. The x plus 1s are both in the numerator, so we cannot reduce that. So x plus 1 squared would be in the numerator. X minus 2 and x plus 2 would be in the denominator. Our excluded values would be x cannot equal 2, x cannot equal 1, x cannot equal negative 2, but also going back to the original problem, we had two factors there. X can't equal negative 1 or positive 1, and we already mentioned that one. So this would be our final answer. Okay. Our very last problem here is a complex fraction. We're going to go ahead and factor this. So pause the video, factor all 4 of those, and then come back here. Okay, let's check it out. We got 5x minus 2 and 5x plus 2 for our numerator, 5x minus 2 and x plus 1 for our denominator, and then the numerator of our denominator, 5x plus 2 and x plus 3 over 4x and x minus 1. So now what we're going to do is we're going to leave the numerator alone, 5x minus 2 and 5x plus 2 divided by 5x minus 2 and x plus 1. We're going to take our denominator and we're going to multiply by the reciprocal of that, so 4x and x minus 1 go to the numerator, and 5x plus 2 and x plus 3 go to the denominator. At which point now we can reduce out 5x plus 2 and 5x minus 2. We are left with 4x and x minus 1 over x plus 1 and x plus 3. We also have to mention our denominators. So anything that is ever once part of a denominator gives us our excluded values. So x cannot equal 2/5, negative 1, 0, 1, negative 2/5, and negative 3. Whew, that's a lot of them. Okay, so that is how you simplify rational expressions. You multiply them and you divide them. If you have any questions, please let me know. Thanks.